Okay, you guys want to go over it together or what?
Sure, let's do it.
This quiz should hopefully be a bit on, I would say it's on the easier side
I wouldn't say.
of what we've done. No, disagree?
This is hard for me. The other quiz was easier.
I just mean like, I think historically people tend to
Is it shorter?
have trouble on some of the other ones more so than this one. But anyway, let's go over it. We'll see. If you have any questions, just let me know. We can address them. Okay, so the first question is just they give you a position function. And then they go, what's the particle's velocity and acceleration at time 2? So the big thing you got to know for this unit here is that if you've got a position function, how do you find the velocity function?
Derivative.
It's the derivative. And then the acceleration function is just the derivative of the velocity function, which I could also think of that as, well, if acceleration is the derivative of velocity, then that's like saying the second derivative of position. So 2 different ways you might think about that. So anyway, for a problem like this, if they just give you a function, my position with t to the okay, so take the derivative, my velocity function will be 4t cubed minus 30t. My acceleration function will be 12t squared minus 30. Everyone okay with that? Hopefully, no problems. And so it says at time 2. So just plug in 2. V of 2 would be, let's see, arithmetic. 8. 32 minus 60, so negative 28. I don't make any boneheaded mistakes there. Obviously, you can maybe jot it down on a piece of paper if you're don't try to do it in your head. But anyway, plug in 2, 4. So 48 minus 30 is 18. So this thing has pretty big values. Negative 28 is the velocity, and 18 is the acceleration. Are there any questions on that? Any confusion? Okay. How about number 2? There's a velocity function, v of t. How will I find the acceleration?
Derivative.
Take the derivative. Now this one's a bit harder. It's not a polynomial. You have to use the quotient rule. So let's do the quotient rule. All right, so you got, although am I forced to use the quotient rule? Yeah, I can rewrite this as t squared plus 1.
We do that one.
Sure. So 10u to the negative first becomes negative 10u to the negative 2 times u prime. So I'd have negative 10 over u squared times u prime is 2t. So does that make sense the way I just did that?
Mm-hmm.
Obviously, if you want to use the quotient rule, that's totally fine too. And now we just have to plug in 2. The question says at time 2. So plug in 2 for all your t's. You get 2 times 2 times 10, or negative 10. It's negative 40. And then 2 squared plus 1 squared is 25. So 8 fifths, negative 8 fifths. What does that mean to put positive 8 fifths in there? What a jerk. Of course, it is good to know if you graphed the velocity time function. Who's that? Who is that? What's his name? Mr. Humpty Dumpty.
Yes.
So you would know before you started that the derivative over here at 2 is in fact negative. So it never hurts to have a graphical mindset. Gives you some extra information. Number 3. There's a velocity function. What's the acceleration at time 4? Same question, pretty much, just a different function. So let's look at that. T squared minus is your velocity, right? My acceleration function would be 2t minus, what is this going to turn into? 8 over root t. Very good, yes. Everyone okay with that? You may or may not need to do an intermediate step and do, okay, 16 times 1/2, t to the negative 1/2. But in any case, you get 8 over root t. And then we got to plug in, it says at time 4. So plug in 4 here, you get 8 minus 8 over 2. 8 minus 4 is, the answer is 4, I guess. No questions on that? For sure? Okay.
Can I use
Oh, this is a tricky one. Select all valid answers. Do you know how many possible answers there are to this?
all the answers?
Well, a lot, but.
7?
6.
Huh?
36. No?
Oh, you're close. It's not 6 squared, it's 2 to the 6.
Oh, okay, my
It'd be
bad.
64. Because because you can select any number of answers, and so each choice can either be yes or no. So 2 times 2 times 2 times 2 times 2 times 2. 64, so that's 2 to the 6th power, 64 possible answers. Obviously, you guys are thrilled with that. Fascinating. Thanks for telling me that.
Some next level permutation.
Oh.
That's actually one of my favorite branches of math, and a lot of people hate it. It's like, how many ways could you?
Oh, that's.
Combinatorics.
No.
I have 5 hats, and I can bring 2 with me on vacation. How many ways can I select 2 hats out of my collection of 5 hats? Combinatorics.
Combinatorics.
Like this. So it's like combinations.
Oh.
So like that. So combinations and permutations. So I'm digging like. How do you guys know the answer to that? If I have 5 hats and I can bring 2 with me on my trip, how many ways can I pick 2 of my hats?
Well, the way I
No,
know
I
it, but the
don't.
way I do it is just fun.
It makes me.
The
It
answer
makes my head.
the answer is 10 if you're.
Write out every possible combination of 2 hats.
You could, yeah. What
No.
if you have 15 hats and you can bring 4 with you? That's gonna take a really long time to write all that out. So there's a whole branch of mathematics that describes this. Okay, so this question says, at what time or times will the particle be at rest? So, okay, at rest means the phrase at rest is equivalent to saying that my velocity is 0. Okay, so am I going to be plugging in 0 for t here?
No.
No, I'm going to be finding the velocity function. So velocity would be 6t minus 24. Then I'm going to set that equal to 0, like that. Of course, the answer to that is 4. There's only one solution. And so there is only one time. Okay. All right, do you guys all feel okay about that one? How to answer a question like that?
Yes, sir.
Okay, great. Number 5. Here's a position function. Particles constrained to move along the x-axis, blah, blah, blah. Its position is given by this function. At what time will the particle's velocity be 3? So again, this is probably the main point of confusion for most students, I think, on this stuff is they go, I get that I gotta pick the derivative, but am I plugging in 3 for t? No, you're setting the velocity function equal to 3. So my position function is t minus 3 squared. And the question we're ultimately going to be asking is, when is velocity equal to 3? And so derivative of this would be 2 times t minus 3. Does that make sense why it's that? I could certainly expand that into t squared minus 6t plus 9, and then take the derivative and get 2t minus 6. But I just use the chain rule. Anyway, if I set this equal to 3, we get what? Now I probably do want to expand this. I don't have to deal with fractions, but ultimately I'm going to have to no matter what. So 9/2 is the answer. Also known as 4.5. AKA. Cool beanies? Chimichanga. I agree. Moving on. Here's a position function. What are you doing? What happened? Like twisting. Here's a position function, and you got to read this question very carefully. What is the particle's position at the moment when its velocity is 4 meters per second? So let's think about what's the game plan here. Obviously, the function's an easy one to take a derivative of. So as long as we have a correct plan, yes, Alyssa, get the plan?
Do you have to figure out what time the velocity is at for and then plug it into the position function?
Perfect, exactly, yes. So you're going to set the velocity equal to 4, and then take that time value that you find and plug that time value into the position function. So first get the derivative. So the velocity is -6 plus 2t. All right, set that equal to 4. So that's 5 is the time value. And then, so that describes the moment when the velocity is 4 meters per second. Now we got to plug that into the position function because the question's asking what is the position at that moment. So it's going to be -6 times 5 plus 5 squared. So -30 plus 25 is -5. All right, that's tricky. The time value was 5, but then the answer is -5 meters. The units are helpful, maybe. 5 meters or -5 meters gives you a hint that the thing I'm looking for is actually a position, not a time. All right. This one says so they're going to give us a position function. And then it says, find the velocity at the moment when the acceleration is some number. So same story. Think in your head here. What's the game plan to solve a question like this? We have the position function. How many derivatives do we have to take? 2. My position function is t cubed minus 5t squared. So velocity function is 3t squared minus 10t plus 1. Acceleration function is 6t minus 10. And the question says the moment when the acceleration is 8. So I set this guy here 8. So the time is 3. And that time is getting plugged in to the velocity function. So velocity at time 3 would be, let's see, 3 times 9 minus 10 times 3 plus 1, so -2. That's neat. Please. So this says, I'm going to give you 2 position functions. Don't be scared by the subscripts. That just says that subscript just means the position of particle A. This one means the position of particle B. What is the position of the 2 particles at the moment when they're traveling at the same velocity? So what's going to be? So what's the first thing I should do? Take the derivative of each function, right? So position of particle A, 3t squared minus t. And the position of particle B is 2.
2t squared plus 3t.
Thank you. By the way, do you guys want that open? Because it's already super glary. Yes? No? You don't want it? You don't want the beams?
Yes.
Lillian, no?
Yeah.
Bailey, you want it?
It's only a few more days left, the light.
It blasted.
Yeah, no kidding. It's gonna be gone here in the next few days.
See you again in March.
Maybe.
Why?
They're so bad this time.
While it lasts.
Yes, they're everywhere.
Yay! So nice out today. Where was I? Okay, so this
Take
question
your son for
says,
granted.
where are the particles when they have the same velocity? So what you gotta do is get the velocity of A, which is 6t minus 1. Get the velocity of B, which is 4t plus 3. And then the question's basically asking us to say, when are those the same? So you set them equal. So you get 2t equals 4, so t equals 2 here. And so that's the time value. Now that time value is going to get plugged back into the position functions. So x sub a of 2 would be 12 minus 2 is 10. And x sub b of 2, let's get rid of this guy. Don't need you anymore. X sub b of 2 would be, what do we get? 8 plus 6, 14. So 10 and 14. Now, be really careful here with the clicks. A was at 10 and B was at 14. Not too tricky, right? A few steps involved, but none of the steps are super sneaky or tricky. This one's maybe a bit of a trickier question. It says 2 of these position functions describe a particle whose velocity approaches 0 as time approaches infinity. There it is symbolically. V approaches 0 as t approaches infinity. Select both.
Could you just graph?
You could, yeah, graphical for sure. But for the millions of fans out there, we're on number 9 right now. So just for the sake of time, I'm not going to write them all out. But I do like the idea of this kind of graphing them all. That being said, the act of graphing them, I think, kind of implicitly requires you to understand their end behavior. So I don't think that, I guess what I'm saying is graphing them is more complicated than just understanding their end behavior. But let's say you are really confident with your graphing skills. It would look like this. Let's look at Birdie. And the last one, of course. I guess the point I'm trying to make as far as for part D, did I really have to know that the graph looked like this? Or did I just have to know that the end behavior was shooting off to infinity? Right? Does that make sense? So really you can rephrase this question. Which of these graphs gets flat? That's all it is, right? Because if your position function is like this, and you're getting flatter and flatter and flatter, what does that mean about your velocities? It means your velocities are approaching 0. Same thing here. Birdie, your velocity approaches 0. Could you take the derivatives of all these and then look at the derivatives end behaviors and see which of these derivatives approaches 0? Sure, but I think it's simpler just to consider the end behavior of the function. So anyway, so the answer would be C and B. Okay. 2 of the position functions below describe a particle that never travels left. Never travels left. So what does it mean if you never travel left?
Never goes negative velocity.
The velocity is never negative. So what does that mean about the slops of the function?
Positive.
The slops are always positive. Okay. So, 10. This is where a combination of like process of elimination / some just general graphical thinking will answer this question. You certainly could take all the derivatives, but that's going to be fairly time consuming, especially for C and maybe A. But so look at A. That's a pretty famous one. Mr. Humpty Dumpty. It's an even function, etc. Does this guy ever have negative velocities? Yeah, right there, for example. So A cannot be the answer. We're halfway there. We just need to rule out one more. There's one that's kind of obvious. D. I mean, that's a parabola, right? Not like we have to know this, but it intersects at 1 and -1. If you like factor out if you think about it in its factored form, then you know our process. But in any case, like, okay, that's negative velocities right there. Okay. So just through process of elimination, we know the answer is B and C, but you know, I think it's kind of neat to just look at the graphs because C looks like this. This is one of those odd functions that we studied. It's like a pre-calculus type thing. So you see how the slopes are always positive? Okay. And then B, that one might be a little tricky to graph, but if you take the derivative, it's 1 plus 5/3 t to the 2/3, which we can tell is always positive. Because it's a birdie, it's a shifted up birdie, right?
Yes.
So for this one, if you actually graph the velocity time function, it would look like a birdie soaring above the x-axis. Always positive. Anyway, B and C. Does that make sense?
Mm-hmm.
All right. I'm gonna do this one. I guess I'll just. Sorry, computer. I'll just do this. So we're hopefully, if you're following this, it's number 11 on the practice quiz. So, how do you get the velocity at time 4.5? What's all you got to do? Just look at the graph, look at the y value. So what's the velocity at time 4.5? 3. And then how do I get the acceleration? It's the slop. Just make sure you're not getting thrown off by units. Okay, this is all 1 meter per second blocks. This is all 1 second blocks. So the slope of this segment here is -2. That should be a fairly straightforward one. Just don't misclick.
Don't mess it up.
Yeah, just don't get it wrong. Easy. Yeah. Pull yourself up. Lit. Same question, or similar question. It's a velocity time graph. So how do I get the acceleration at a certain time? Actually, no, I'm sorry, I misread it. It says, find the acceleration at the moment when the velocity is 2.5. So where's the trick answer? The mean answer. No, that's the correct answer.
Ah, sweet.
-2 is the correct answer. I was thinking 0 is the mean answer because if you misread this like I just did, misread my own question as what's the acceleration at 2.5 seconds, you might look over here and go, oh, the slope is 0. Oh no. So what it's saying is when the velocity is 2.5, so you got to look up here. Well, this is the moment. You guys see where obviously see where I'm pointing, but that point right there, basically at 0.5 seconds is the moment when the velocity is 2.5. And so the slope on that section is, wait, is it a -3? God, I'm having a rough one. Just testing you guys. That was just a test, yeah, for TikTok. Okay, number 13. Everyone's cool with that. Sorry if I confused you. The slope here is -3, not -2. Hello, Mr. Osborne. How's it going?
What are you guys talking about today?
Nothing. Just
Derivatives.
TikToks.
Just TikToks. TikToks
TikTok.
only.
Yep.
That sounds like a good day.
Reptilian
Reptilians.
humanoids.
Oh, yeah. Did you watch Parks and Rec?
I've seen it. Yeah.
There was a group of people that worshipped a reptilian humanoid that would end the world. And they were always yeah, Zorb. Yeah, Zorb. Yes,
I
yes.
don't remember that episode.
That's a good episode. Yeah, great.
Classic. Yeah. I did like that show. It's a good show. I just remember that scene where it was, I think it's Andy. Isn't it? What's Chris? Not Chris Pine. What's the guy's name? Chris Pratt. Is that his name? Andy in the show?
Yeah.
Someone's like, Andy, are you okay? And he's like, yeah, I'm fine. Just just everything sucks and everything's pointless and I can't sleep and I can't enjoy any of my hobbies or something like that. He just
That's
describes
rude.
being in like a miserable state. So, but I'm fine. No worries. Yeah, he needs to get some
That's
bootstraps.
how it be. That's how it be.
Yeah, it do be like that, yeah. Anyway, so again, velocity time graph, it says, what's the time interval or intervals, plural, when the particle is traveling to the right? So this is another one that can be confusing. You know, it's tempting to look at this and go, oh, whenever the slope is positive. That is not correct. Okay? Traveling to the right, so I'll write it up here. Traveling right is the same as saying that the velocity is positive. So if it's a velocity time graph, you're really just looking at what time intervals is the graph above the x-axis, above the time axis. So that would be 0 to 4 and from 9 to 10. Are we all okay? There's no confusion on that one? If this had been a position time graph, then we'd be looking at when is the slope positive. Okay, so it's a subtle difference, but it's pretty critical. If you want to understand like what's going on with this stuff, understanding how you can describe motion graphically, that's a pretty key concept to make sure you understand. All right, so anyway, I guess I can move this. Hold on. These graphing ones are just tough to do on the whiteboard. Just when I put this here, I feel like you can't see the board very well. But okay, hopefully you can.
Every time you step in front of the screen, it like
It becomes like a lamp.
yeah.
If I do this, yeah, it'll be like this just white screen. So I've been trying to do them on the board more. But
Just for grip.
just, yeah. Okay. So this one says we're going to find the average speed and average velocity from time 0 to time 10. So this question is not easy, but it also doesn't require a ton of calculation. So what makes it a little tricky is you might overthink it. You might go, wait a second, there's all these velocities happening, all these tangent lines, all these slopes describe the velocity. How can I possibly average them? Well, you don't really have to do it that way, even though technically that is what you're doing. How do I get the average velocity? Yeah, take the total displacement. So where did I start? 4, ended at 0. So my average velocity is -4, and then my total time is 10. So that's -0.4 for my average velocity. Does that make sense? So as you can see, once you know the secret, right, it's an easy calculation. Okay. Average speed is a little bit more difficult. You have to treat all the motion as positive. So you have to go, I went from 4 to -2. So that part of the trip, how far did I go? 6. Then I went from -2 back to 3. That's a distance of 5. And then I went back down to 0. That's another 3 units. So I went a total of 14 units, and it still took 10 seconds. That's 1.4 meters per second. Okay, that makes sense? Okay. Almost done, guys. We're almost out of time. I think I would know the schedule by now. It's only been a few months. All right, the last couple shouldn't be too hard. Should be pretty kind of fast. All right. This one's also extra tricky. When is the particle stationary if I give you a position time graph whenever the slope is 0? Remember, stationary means that the velocity is 0. How do I get velocity off a position time graph? The slope. Okay, so at time 2 and time 6 is it. All right, last couple would be, here's a velocity time graph. Which is,
These hurt my head so much. Oh, just thinking about it. I get them eventually. They just make me oh.
yeah, there's no need to do them super fast, just take your time. So you go, okay, so this graph is the derivative of the answer, right? So this says that I had a positive velocity, then a 0 velocity, and then a negative velocity. So I need to find a graph that goes positive slope, 0 slope, negative slope. Which one does that? Choice A. Are we okay with that? Okay. Same idea. This one says I always have a positive velocity, but my velocity seems to be getting closer to 0 as time goes on, right? So velocity starts off big positive, stays positive the whole time, but it's actually getting smaller as we go. So which one of these has a positive velocity the whole time? C. You can also see it's kind of curving. It's getting less slothful.
Teachers, at this time, please release all students to advisement. And
The last
students,
two are-
after advisement, please proceed to your fourth period.
The last two are negative,
Please
positive,
release all students to advisement
C.
at this time. Thank you.
and then 8, then 19 is negative slopes the whole time. So that's going to be choice A. So those last couple should be hopefully pretty intuitive.
Or I guess go just go sit.
All right. See you tomorrow.
He's not even a